Good morning. I am myself Senthil, working as assistant professor in S.A.ENGINEERING college. So today's topic what I am going to taking is design strategy. So totally we have two type of design strategy. So one is black box testing, another one is white box testing. So first we go in with black box testing. So black box testing. So before I am going to start with the black box testing. So for any software development, so we have three main parts. So one is the input, second one is the process, third one is the output. So in black box testing, the tester is going to focus on only what is the possible input and what are the possible output. The tester does not know the knowledge about what structure that we are going to use, what program that we are going to use. So only we are going to check what input and what is the possible output. So we have different types of black box testing. So among this 9 black box testing, so we are going to see some of the few important black box testing. Random testing. So in random testing, what we are going to do is we are going to check a random input. So we will give a random input and we are going to test whether it is pass or fail the test conditions. So let us consider a simple example here. So we are given a random inputs. So we have 1, 2, 3, 4, 5, 6. So 6 random input we are going to give. So we are going to give the test conditions here. So here we are going to give a for loop. So int I is equal to 1, I is equal to 0, I is less than equal to 5, I plus plus. So first we are going to check value of I will be 0 and 0 is less than 5. The condition will be true and the value of x. So x is given as an array here. So x of 0 quotient. So x of 0 quotient 10. So 10 will be given as an input and the condition will be checked. If the condition is true, the 10 is a positive number. Likewise, the random input is going to be given and we are going to test whether it is test condition is passed or failed. Next type, requirement based testing. So in this requirement based testing, what we are going to do is we are going to gather the information from the customer. Then the gathered information we are going to check whether it is correct or not, and it is unambiguous. So unambiguous means it is a clear version. So the gathered information should be very clear and it should be easily understood by the developer because the developer is going to develop the project. So in this requirement based testing, so first we are going to have a complete blueprint about the project. So before we are going to test the conditions, we are going to have a budget. So based on the budget, the tester will have two type of requirement. One is high level requirement, second one is a low level requirement. So this requirement will be have a meeting with the customer, and customer, based on the customer satisfaction, the developer is going to select which requirement is best. So after finding the evaluation, we will find that the complete requirement based on the requirement based testing. Next step, equivalent class partitioning. So here what we are going to do is, so before the software project is going to be completed, and we will give a equivalent class. What is the possible valid input and what are the invalid output. So we are going to check the valid input and invalid output. So this is the system we are going to test. Okay, so in this we have a valid input, we are going to test an invalid input. This invalid input, what will be the possible invalid output, and this invalid input, what will be the possible invalid output. So this type of testing is nothing but equivalent class partitioning. Next, boundary value analysis. So in boundary value analysis, what we are going to do is, first, with the help of this equivalent class partitioning, we will have a n number of input data. For each and every input data, we are going to set the analysis. That is boundary value analysis. How we are going to set the boundary value? According to the rule of thumb, we will set the value above and below of the input value. Let us consider minus 1.0 and plus 1.0 with the input value. Let us consider minus 1.0 and plus 1.0 as the input value. According to this rule of thumb, so we are going to identify the above value and the below value of minus 1.0. The above value is minus 1.1. The below value is 0.0. Likewise, we are going to find the above value of plus 0.1. The above value of plus 0.1 is plus 1.1. The below value will be 0. So with the help of this rule of thumb, we are going to have a n number of value. In this, we are going to collect this minus 1.1 and this plus 1.1, and already we have minus 1.0 and plus 1.0. So that is the value input. Okay. So this is how, with the help of this boundary value analysis rule of thumb, we are able to identify. We are going to set the boundary for the input values. Next type, state-based testing. So in state-based testing, what we are going to do, first we are going to identify the components for each and every system. So after identifying the components for each and every system, then we are going to identify the possible state for each and every components. After identifying the possible state, then we are going to find the possible action for each and every state. So after I identify the components, state and action, so with the help of this three part, we are going to draw a state-based diagram. After a diagram is going to be drawn, we are going to test the valid and invalid test conditions. Now we can see. So here, let us consider a simple example. So in state-based testing, I am going to take a mobile banking system or internet banking system. You can take. So first thing, this is start state and it is a log state. So the first state will be a log state. So then we are going to give a correct username and password, and the signal should be iStealth. So if the username and password is correct and the signal is correct, and it will be log state will be converted to unlock state. So that is the one type of transaction. Next, if I am going to give an invalid input or the signal strength is very less, then it will be moved to locked state to unlocked state. That is accepting state. So in this accepting state, we will have more attempt. The second attempt you are going to give. So in the second attempt, so correct input I am going to give, or due to some network failure, the attempt may become failure. So that is, you will have a n number of attempts. In the second attempt, if I am going to give a valid input and the signal strength is very high, so this accepting state once again it will be changed to unlocked state. So when the state is unlocked, we can see the balance, we can transfer the amount, or we can close the account. So in this state, if more number of attempts, for example, if the bank is going to have 3 or more attempts, so after that it will be blocks. So that is we call as a block state. So once the more attempt is we have reached, so this acceptance state will be moved to the blocked state. So this is how the state-based testing will be tested. So here we will have 4 states: locked state, unlocked state, accepting state and blocked state. And 2 even we are going to have, one is valid key and an invalid key. Totally 5 valid transactions. The first transaction is locked to unlocked. So that is locked state to unlocked state. Next, locked to accepting state. If we are not going to give a valid input, so correct username and password, so this locked state will be moved to acceptance state. Next, acceptance to acceptance state. So acceptance state to acceptance state, we are going to have more number of attempts. If we achieve more number of attempts, so this state will be occur here. Then accept into unlock. If the second attempt we are going to give a correct username or password, so this accepting state will be moved to unblock the state. And final state will be accept into the block state. If you are going to reach a maximum attempt, so you will get an error message like your account or your login is blocked, and you can meet the nearby banking customers or bank service like that. So it will move to block state. This is how the state-based testing will be tested. Next, the final testing is black box testing is compatibility testing. So in this compatibility testing, what we are going to do is, so before the software the project is going to develop, so first we are going to check what will be the hardware configuration to develop this software. That is the first step we are going to do. Next, if my software is going to have some external peripheral like printer I am going to connect, or the DVD I am going to connect, I am going to test. And if my software is going to have work with networking, so I am going to check with the bandwidth capacity. And if my software is going to work with what type of OS, whether it will be Unix, or it will be Windows, or it will be a Mac OS. And if my software is going to connect it with a database, so what type of database I am going to use? So it is an Oracle or SQL Server or MySQL. And finally, my software is going to run with the web browser. So what browser is adapt for my software? It is a Chrome or Firefox or Internet. So this type of testing will be tested under this compatibility testing. So with this we have completed black box testing. So black box testing, almost we have 9 types. So in this 9 types we have seen some of the important types of black box testing. Then we move on to white box testing. Next, white box testing. So white box testing is quite opposite to the black box testing. So in black box testing, what I told you, so the tester is know about only what is the input and what is the output. The tester does not know about the knowledge about the process, what structure that you are going to test it, and what program that you are going to run, and what logic that we are going to use. But in white box testing, we are going to focus only on the process. The tester will know about what logic that you are going to use, what technology that we are going to use. So all the things will be tested. Mainly the source program will be tested in white box testing. So we have different types of white box testing. So totally we have 9 types. So among these 9 types, I am going to explain some of the few important white box testing. So first testing, code functional testing. So in code functional testing, the actual source code will be tested. For example, if the number of code, if 4 or 5 lines, it will be easily tested. If it's in the case of if the code will be 100 lines, so how the source code will be tested. For that reason, this code functional testing will be used. So here what we are going to do is, we are going to convert the source code into graph. So a picture representation. So a picture representation means, so you can easily identify the errors, and the developer can easily understand the concept, and he can easily identify the errors, and the tester can also easily identify the errors. Okay. So before the source program, so we have 3 main parts to develop a program. So first is sequence, second is decision, the third one is iterative. So for the first one, sequence. In sequence structure, so we will not use any if condition or loop condition. The program will be simple like that. And in decision, we use if else and nested if. And for iteration, we use while, do while, and for. Based on this prime 3 major part, so we will use to build the program. So based on this program structure, these are the coverage. In code functional testing, these are the coverage that we are going to do. So functional coverage, statement coverage, branch coverage, condition coverage, path coverage, entry and exit coverage, loop coverage, and state coverage. So this coverage, this type of coverage we are going to do in code functional testing. So I have shown a simple example about how the source program will be converted into graph. So first there are 2 main things. So first a simple statement, second one is a if condition statements, if else or while or do while for statements. Right? So for simple if condition statements, we will use 2 type of structure. One we call as it is a rectangle, or the second type we will use an oval type structure. Okay. So let us consider this diagram. So how this diagram will be converted to, how the source code will be converted to the diagram. So first the program sample, this is the first line, and it will start from the start and it will end with the exit. So first we will have program sum, and these are the input. This input will be converted as a rectangle box. Next, the conditions. I already told you the conditions. If conditions and while condition, it will be used as a triangle shaped symbol. So why we use for the condition symbol as a triangle shaped symbol? The condition we are going to check whether it is a true or false. If it true, it will move to the true path. If it false, it will move to the false path. So in triangle case, we have a 3 terminals. Whether you can go with the positive or whether you go with the negative part. Okay. So for this, for if condition, we are using this, and the while condition we are using this, and inside that while condition again a if condition using this. So easily you can transmit this source code will be converted into graph. So once this graph will be converted, the tester can easily test it, and the tester can easily identify the errors. That is the main reason that we are going for the source code will be converted into graph. Next type, code covering logic. So in code covering logic, actually the same thing. The source code will be converted into table format here. Okay, the first type we are going to, what we have seen, the source code will be converted into graph. Here the source code will be converted into table format, and the table structure what we are going to design, the tester can easily test it. Okay, here in code coverage testing we are going to give 100% result. So we will produce 100% result. Now we can able to see how we are going to convert the source coding logic into the table format. So let us consider here we have a source code here, and we will give a condition. There are two conditions. If age is less than 65, and the second condition is marriage underscore true. These are the two input conditions. If two input condition is going to true, then do X and do Y. If this two condition is going to false, we are going to have do Z. Okay, this is the source code program. How the source program will be converted into table. So now I will clearly explain. So first, the two columns represent the input condition values. So the first column will be the age value, the second column will be the marriage value. And based on this two value, I am going to set the condition 1 and condition 2. And based on this two condition, I am going to decide the decision outcome. And finally, for each and every test cases, I will have a test ID 1 and 2. Let us see the first condition. If my first condition input value, my age value is 30. So 30 is less than 65. Then the marriage status is true. If the age condition 30 is less than 65, the condition is true, and the marriage age condition is true. That is as shown in the third and fourth column. So true, true. If both conditions true, I am going to use a AND. So AND means the both conditions should true. Then only it will go for do X and do Y. That is the true part. Okay. So if both the conditions are true, the outcome will be true. And this test case will be identified test ID 1. The same wise, I am going to give the second value as the my age value will be 75, and my true marriage condition will be true. So age condition is 75. So 75 lesser than 65. So this condition will be became false, and this condition is true. So false and true. If false and true comes, and what will be the output? False. This is my test case 2. Likewise, for each and every condition we will check. So with the help of this, we can easily identify the errors, and the tester can easily produce 100% results with the help of code covering code logics. And third type is covering independent path. So in this covering independent path, so there are three main steps that we are going to use. The step 1 will be control flow graph. So the source code will be converted into control flow graph. The second step 2 will be we are going to find the cyclometric complexity, and third step we are going to do independent basic path. So first we go with control flow graph. How the source code program will be converted into control flow graph. Here the source program. How the source program will be converted into control flow graph. As I told you before, so the simple statements they will be converted as nodes. Okay, here this is the main function and this is the input. So this two statement will be converted as a single node, and then the while condition. So this while condition I am going to add a condition node, that is a triangle node. So in this while condition true, a true statement for this node will be converted as a single node. Here I will use, so this is node 1, and this is node 2, and this is node 3, node 4, node 5, node 6. Okay, so node 1, here is node 1, this is node 2, this is node 3, 4, 5, 6. So now you can easily understand this node 1 will be converted, this program will be converted as a node, and this condition symbol will be converted, that is node 2, and 3 will be the true statement of this while condition. So it is a rectangle. So then the system.out.println else part, and the 6th node, okay, will be add this. Okay, so this now will be converted, this source program will be converted into graph. So we have completed the first step. The second step is we are going to find the cyclometric complexity. So in cyclometric complexity, so what reason we are going to find the cyclometric complexity means we are going to find the complexity level of the program. So in order to find the complexity level of the program, we will have a simple 3 basic formula. So first is vertex of G is equal to number of simple decision plus 1, and vertex of G is equal to number of enclosed area plus 1, and final vertex of G is equal to number of edges minus number of nodes plus 2. Okay, so now we will have So first vertex of G. Number of simple decision plus 1. So number of simple decision plus 1. So number of simple decision is the condition symbols. So here in this given graph, so how many condition symbols we have given? So 1, 2. So totally 2 condition symbols, that is dimension symbol we have used. So 2 plus 1, that is equal to 3. So according to the first formula vertex of G, the answer value will be 3. The second formula vertex of G, number of enclosed area plus 1. So in this given graph, we are going to find how many enclosed areas are there. So you can check it which enclosed area. This is the open area. This we have one enclosed area. We have second enclosed area totally. So first enclosed area and second enclosed area. So totally 2 enclosed area is going to be given in this graph. So according to the formula, so the number of enclosed area will be 2 plus 1, that is equal to 3. According to the second formula, the answer value will be 3. Then the fourth vertex of G is equal to number of edges minus number of nodes plus 2. So first we go with the number of edges. So number of edges means, these are edges. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So vertex of G equal to number of edges will be 8 minus number of nodes. How many nodes are there? So 1, 2, 3, 4, 5, 6, 7. So totally 7 nodes and plus 2. So 8 minus 7 will be 1. 1 plus 2, that is equal to 3. So the last formula for vertex of G is equal to number of edges minus number of nodes plus 2, the value will be 3. So you can see according to this 3 formula, so all these 3 formula will have the common same answer 3. Okay, that shows the formula that what you are going to calculate is correct. Okay, this is step 2. So step 2, what we are going to find? We are going to find the cyclomatic complexity of the given graph. So final step 3. Step 3 is we are going to find the independent path. So before you are going to find the independent path, so you have to give a number to the nodes. So total numbers we will see. So this one is 1, 2, 3, 4, 5, 6, 7. So you have to give number for each and every node. Then only you can easily identify the paths. So how you are going to identify the path? So you have to go with the positive, the true path, and the negative and the false path. So first we go with the positive path. So first we go with the path 1. So path 1 will be 1, 2, 3, 4, 6, 2 and 7. So 1, 2, 3, 4, 6, again 2, 7. This is the path 1. So second part, what we are going to do is, so we are going to first going with the positive, that is the true path for this condition. So second path will be the negative path, that is the false path. So that is 1, 2, 3, 4, and the negative path 5. Then again 2, 7. So for this condition we have covered the positive path and the negative path for this condition. And third path will be, for this condition we have to identify the false path. So the false path will be 1, 2, 7. So these are the maximum number of paths in this the given graph. So total path will be 3. So the final conclusion for this path coverage is, so based on the step 1, what we have done in the step 1, so we have convert the control flow graph into program into control flow graph, that is the step 1. and step 2 we are going to find the cyclometric complexity, and after completing cyclometric complexity, my complexity level will be 3, and finally we are find with the maximum number of path, the maximum number of path will be 3. If the cyclometric complexity level and the maximum number of path will be matched, then we can declare that the graph that what you have drawn is correct. If it mismatch, the graph what you have drawn is wrong, again you have to redraw the graph. This is how this control flow graph will be working. So within this we have completed black box testing. So we have seen white box testing and black box testing, and this is very important part in software testing concepts. Next we go with the MCQ type question, gate questions. The first question: what is the primary goal of black box testing? So the primary goal of black box testing is you are going to find only what will be the input and what will be the output. We are not going to see the internal structure or anything. So we can check this to validate the internal code structure. So we are not going with the internal code structure. And to find the security, we are not going with the final security. To verify the functionality of the software, then the D option is to review the source code. Here, this is a wrong option, and we are not dealing with the code structure. So we are dealing with to verify the functionality of the software. That is option C. Okay, because the black box testing only we are going to focus on the input and what will the output. We does not focusing on the internal structure of the process. So question 2. Which of the following is false about the performance testing in software engineering? So among this given statement, we are going to identify the false statements. So first, the performance testing. So performance testing is a system testing. It is correct. Performance testing check whether the system meets the non-functional requirement. It is correct. And performance testing is a test testing comes under performance testing, which is correct. And it is generally a white box testing. Now only we have seen different types of white box testing. Among the different types of white box testing, we does not come across the performance testing. So which of the following is false? So this option C will be false, because the performance testing is not concentrated on white box testing. It will not comes under this white box testing. Now question 3. Which of the following is included in primary structure of the program? So we have seen, so to build a program, we have seen 3 major types. Okay, the first one is sequence, second one is decision, the third one is iteration. So here we have given the option iteration. So check is wrong, verify is wrong, and receive is wrong. So the option B is correct, iterative. So iterative means loop concepts. Next, we have to find the cyclometric complexity. So as you all know, the formula to find the cyclometric complexity, the first formula is vertex of G is equal to number of sinful decision plus 1. So number of simple decision. So number of simple decision is the conditions. So condition means the diamond shaped symbol. So how many diamond shaped symbols there? 1, 2, 3. So totally 3 diamond shaped symbol. So 3 plus 1, that is equal to 4 according to the formula 1. And what will be the next formula? Vertex of G is equal to number of enclosed area. The number of enclosed area plus 1. So how many closed areas is there in the given graph? So 1, 2, 3. So totally 3 enclosed area. So according to the formula 3 plus 1, that is equal to 4. That is according to the second formula. Option A is the correct answer. So question number 5. Which of the following testing is also known as white box testing? So white box testing, as you all know, white box testing is a structural testing. And it is other name for the white box testing is a black box testing. So among this given answer, the structural testing is the correct answer. So that is option A. Okay. Which testing technique is used for covering code logic? So now we have seen already covering code logic. So covering code logic, so what we are going to do is, so we will have the source program. The source code will be converted into table format. Okay. So the option is B. So B is a correct option. So we have seen 6 MCQ type question that can be given in the gate. So based on this topic, it's very easy to understand the different strategy that we are going to use in software testing. And this we are completed. Thank you once again for giving this opportunity. Thank you all.